Now in this question number 52, a given object takes n time more time to slide down 45 degree on rough inclined plane as it take to slide down perfectly smooth 45 incline. Coefficient of friction निकालना है. So there are two inclined, one is smooth and other is rough. Okay, the rough has a coefficient of friction mu. We have to take same length of inclination in both the cases. Let's say LL. Now what is the acceleration of the block on a smooth surface? It is g sine theta. And what is the acceleration of the block on rough surface? It is a equals to g sine theta minus mu cos theta, right? So when you put 45 degree, it will come g by root 2 1 minus mu, same is here, g upon root 2. Now we'll be using the formula of s equals to ut plus half at square, and in both the cases u is 0. Therefore for a smooth surface we will write L equals to, u will be 0, so directly half into a means g by root 2 into t square. Okay, t is the time taken by the block to slide down on a smooth surface, and according to the question nt is the time it take to slide down on the rough surface. So this is your equation number 1. Second equation on the rough surface will be half g by root 2 1 minus mu into nt whole square, equation number 2. Now we have to simplify these two equations to get the relation of mu and n. So if I can see it directly, we are getting 1 equals to 1 minus mu into n square, getting L cancelled, half cancelled, g by root 2 cancelled, and t square cancelled, right? And after rearrangement we get mu equals to 1 minus 1 upon n square. Do your calculation to verify this solving. This will be the answer. So answer is B. So in this question, determine the time in which the smaller block reaches the other end of the bigger block. See, in the given situation, the bottom part is smooth and the upper part has coefficient of friction 0.3. A 10 Newton force is acting from the left side on 2 kg block. So first identify the direction of friction. So on 2 kg the friction will be acting on left side, and on 8 kg friction is acting on the right side. This must be a kinetic friction in order so that the block 2 will move on, block 2 kg will move on 8 kg to fall off on the other side. How much is maximum friction? It is mu into mg from here. So 0.3 into 2 into 10, and we are getting 6 Newton, right? Now you see, because there would be slipping between the two blocks, otherwise 2 kg will not fall. So what we can find, the acceleration of the two blocks separately. So on 8 kg friction is acting 6 Newton on the right direction, and it will have acceleration of a2. So equation will be mass into acceleration equals to force acting on it, that is 6, right? So a2 is coming 3 by 4 meter per second square. This is the acceleration of the lower block on the right side. Now same thing for the 2 kg block. On 2 kg block, 10 kg acting on the right, friction acting on the left, which is 6 Newton, and it has an acceleration a1. So mass into acceleration equals to 10 minus 6, this is the net force, that is 4 Newton. So a1 is coming as 2 meter per second square. What is the relative acceleration? Relative acceleration will be a1 minus a2, means the acceleration of block 2 with respect to block 1, 8 kg. So it is 2 minus 3 by 4, which will give you 5 by 4 meter per second square. Now with this, the 2 kg is slipping over 8. So length to be covered by the block on 8 kg block is 3 meter. We'll be using the formula S equals to ut plus half at square, and u will be 0 in this case. So S equals to half at square. Time has been asked, so it will be 2s upon a. Now substitute and simplify it. So root under 2 into 3 upon 5 by 4. So 4 will go in numerator. So this is root under 24 by 5. Approximately 5 आएगा और इसका स्क्वायर रूट लोगे, that comes approximately 2.19 second. So the answer is C. In question number 55, there is a rough horizontal surface on which a body is thrown with 6 meter per second, which stops after covering 9 meter. So what is the coefficient of friction? Mu we have to find out. See, there is friction and which is opposing the motion. So that friction is basically mu mg on the block, which causes retardation. So I will equate it to ma. M cancelled. A equals to mu g. Right. That is 10 mu. Now using S v square equals to u square plus 2as, get the acceleration and use this 10 mu to simplify it. So for v square equals to u square plus 2as, we say 0 equals to 6 square minus 2 into 10 mu into 9, right? So we are getting 36 divided by 18 into 10, and so we are getting 0.2. D is the answer to this question. In 56, the block is sliding down. So what will happen in this case to the block? So what we see here is tan 30, which is 1 upon root 3, and it is slightly less than 0.6, जो coefficient of friction है उससे कम है. So here the mu is dominating over inclination, so the block has a stopping tendency, means retardation tendency. So the speed of the block is decreasing and will stop at some point of time. So the answer to this is C. So in question number 59, given is the upper part of the inclined plane is smooth, that is A to B, and the lower part is rough. They are equal in length. Let us call their length as LL. Block is starting from rest at A equals to 0 and will again come to rest at C. It is being said in the question. So we have to find the coefficient of friction of the lower part. We have to find what is mu over here if it is the case. See what happens on the smooth surface. The block will gain speed because of g sin theta acceleration, but then it stops in this part, and definitely to stop this, friction force would be greater than mg sin theta. So we will say that A बराबर mu g cos theta minus sin theta into g sin theta. This would be the retardation and direction would be upside. Friction force would be greater than this, only then it will stop while it is reaching at C point. Okay. Now we have to use the formula and assume also that it has gained the velocity v at point B, which is the initial point for the lower part and final point for the upper part. Now use the formula v square equals to u square plus 2s for the both part. So for AB part, we'll be using v square equals to 0 plus 2L into g sin theta. Okay, this is equation number 1. For part BC, initial velocity is 0, final velocity is 0, initial velocity is v. So 0 square equals to v square minus 2 L Yeah, minus we are taking because it is the case of retardation and A is upside, right? And A कितना होगा? तो A will be G bracket में mu cos theta minus sin theta. This is equation number 2. Now simply we have to put this V square here and to simplify it. Okay. So on solving this, means I am substituting V square in equation number 2, we get 2LG into mu cos theta. You will do your calculation over here, equals to 3 sin theta into G. Yeah, it will be 4 sin theta into GL. So GL and GL will get cancelled, and we are getting mu equals to 2 tan theta after solving this equation. So the answer is A to this question. So in this question, a block is gently placed on a conveyor belt moving with constant speed horizontally. In 4 seconds, the velocity of block become equals to the velocity of the belt. Find if the coefficient of friction is 0.2, what is the velocity of the conveyor belt? Let the conveyor belt velocity is V initially. Now as a ground observer, what you will see, the block was gently placed, so initial velocity of block is 0, and finally the block would be moving with the belt, so block velocity will be same as that of belt, means V. But we will solve this problem with respect to belt, which will become a little simpler. So what appears to be the velocity of the block with respect to belt initially, it is V left side, right? And finally when block come to rest with respect to belt, the final velocity of the block will be 0. So initial velocity is V with respect to belt, and final velocity of the block is 0. Now what causes this? So there is acceleration, which is mu into G, that is 2 meter per second square. Mu is 0.2 and G is 10, and we have the time in which this is happening. This is 4 seconds, right? So what is the initial velocity? The formula that we'll be using is V equals to U plus AT. Final velocity 0, initial velocity V minus 2 into 4, and this is giving us 8 meter per second, right? So the answer is A. Again same question on the same line. In this case there is an inclination given at 30 degree, and a block is thrown up with 5 meter per second, which stops at some point of time. So there is a retardation, or called acceleration downward, which is given as G sin theta minus mu cos theta. We have to find mu, so we can at least put theta over here, 30 degree. So G into 1 minus root under 3 mu upon 2. This is the retardation in the block. Okay. Time given 0.5 second. So again V equals to U plus AT, and from there we can get V equals to U plus AT, 0 equals to 5 minus G by 2, 1 minus root under 3 mu into 1 by 2. So we need to simplify this expression. Okay, we have to make a change over here. Since the block is moving up, so friction force is also acting downside, and mg sin theta is also acting downside. So acceleration downside will be g sin theta plus mu cos theta, क्योंकि दोनों ही नीचे की ओर है, ठीक है. So यहाँ पे प्लस रहेगा, and this will be also plus. Now on solving this equation, we will get 1 upon root under 3, which comes 0.57 after solving this, right? So this is close to 0.6. So C will be the answer to this question. So in question number 62, the friction force acting on the car is 500 Newton, which will bring it to rest from 30 meter per second, and the mass is given 1000. Okay. So retardation in this case will be given by friction as F upon m, and this is coming 5 meter per second square. Because final velocity is 0, so we can use the formula. We have to, this time is equals to this time is equals to u upon a, and u was 3, so 30 by 5, it is coming 6 meter per second, 6 second, not meter per second, 6 second. So the answer is C. Okay. So in question number 64, a 4 kg block is given and a force F equals to kt, and k is given 2, so 2t square is acting on it. कोफिशिएंट ऑफ फ्रिक्शन दे रखा है 0.8 और 2 सेकेंड पे क्या फोर्स लग रहा है, फ्रिक्शन फोर्स क्या है ये बताना है. वी हैव टू फाइंड फ्रिक्शन फोर्स at t equals to 2 seconds. So first of all we have to check whether will block start or not moving at t equals to 2 seconds. For that, first you find the maximum friction force which can be acting on the block, and that is coming 0.8 mu mg into 4 into 10, that is 32 Newton is coming, right? Now what is the force acting at 2 seconds? Put 2 in place of this, we are getting 8 Newton. Okay, since this external force is less than F max, so block is not moving. Okay, block is not moving. Now if it is not moving, in that case the applied force is equal to the friction force. So friction force acting is 8 Newton in this case. Answer is A. Now in this question, a block which has a weight of W W is being pushed like this, making angle theta with the horizontal, right? Angle of friction is given phi, so angle of friction is given phi means tan phi equals to mu. Okay, the force, the magnitude of force required to move the block will be, now you have to resolve the force like this and this. So ऊपर n लग रहा है, नीचे f sin थीटा आएगा, हॉरिजॉन्टल डायरेक्शन में f cos थीटा आएगा because cos theta is here. Okay, and the friction will come on the left side. Now in order to move, this n will be equals to mg plus f sin theta, y axis से आएगा, and to move f cos theta has to be greater than equals to friction maximum, that is mu into n. We'll put n over here and then further simplify it, we'll get mu mg upon mg minus cos theta minus mu sin theta. Okay, now you have to put tan theta in place of mu, and to further simplify it, so you will find f is greater than equals to mu के जगह पे तो tan phi put कर देंगे, and w in place of mg, और नीचे में after solving we'll get cos of theta plus phi, right? एंड डिनोमिनेटर में cos phi रहेगा, यहाँ पे cos phi रहेगा तो वो ऊपर से कैंसिल आउट हो जाएगा. सो विल गेट sin phi into w divided by cos of theta plus phi. B will be the answer to this question. Now in this question they are asking for if the line joining the center and the hemisphere makes an intersect angle of alpha with a vertical insect makes with an angle of alpha with a vertical, the maximum possible value of alpha without slipping would be, right? See, if you go for with a direct कि slipping के लिए angle of repose में हमने क्या पढ़ा है, तो angle of repose में जो थीटा है ना, यहाँ जो अल्फा है ना, वो थीटा आएगा. It will be mu, that is given as 1/3 and cot alpha equals to 3. ऐसा करके आंसर आ जाएगा. So we can answer this A. And if you go for the further detail in this, so you need to extend the line like this and this. Okay, mg is acting in this direction, so mg will be resolved here and there. अल्फा है तो इधर mg का साइन अल्फा आएगा, mg cos अल्फा आएगा. n is acting perpendicular to the surface, and here is the friction, and that too which is maximum, mu mg cos अल्फा in order to just slip. ओके, नाउ अगर आप दोनों को इक्वेट करोगे वापस से tan अल्फा इक्वल्स टू म्यू आ जाएगा, एंड दैट विल सॉल्व टू गिव यू आंसर ए. सो इन दिस केस inclined plane is given at an angle of theta, and there is a block of upward force F is applied just to prevent it from slipping down, and when you apply 2F, the block will be almost ready to move upside. So basically this is the minimum force required to keep it at rest, and this is the maximum force required to keep it at rest. As I have already discussed in the class, F minimum जो होता है यहाँ पे वो हो जाता है mg sin थीटा माइनस म्यू कॉस थीटा, ठीक है ना, और प्लस कर देंगे माइनस के जगह तो मैक्सिमम हो जाता है. सो सिंपली अकॉर्डिंग टू क्वेश्चन F इक्वल्स टू mg sin theta minus mu cos theta. This would be your first equation for just to prevent the block from slipping down. For maximum we have to use plus sign, so maximum force is 2F equals to mg sin theta plus mu cos theta equals to, right? Now we have to eliminate F in order to simplify it. So multiply by 2 in equation number 1 and then make it equals to equation number 2 to get it solved. Okay, so we will get 2 sin theta minus 2 mu cos theta equals to sin theta plus mu cos theta. एक साइन कैंसिल आउट हो जा रहा है, and we are getting mu equals to tan theta by 3. Okay, so the answer will be A. Now in this question, under what condition M2 will start moving upward? Okay, so when it try to move upward, इस पे पीछे लग रहा होगा maximum friction जो कि mu m2g cos theta होगा. At the same time mg sin theta, m2g sin theta is also acting. Here is the tension T, here is the tension T, और यहाँ नीचे लग रहा है m1g. Okay, now in order to move, T must be greater than equals to mg sin theta, m2g sin theta plus mu cos theta. तो इक्वेशन देख करके लग रहा है कि B ही आंसर होगा. Now from the other side of the block means m1 से अगर मैं देखूँ तो T बराबर m1g आ जाएगा. So I will put here m1g. This g and g cancel out, m2 will come in denominator of m1. So this is something like this. Okay, so B is the answer to this question. So in this question, block M is given a force, and this force is basically capital mg at angle theta with the vertical as shown in the figure. So what should be the condition so that the block is pulled with this force, right? So सबसे पहले आप क्या करेंगे, forces को मार्क करेंगे और जो नहीं है एक्सेस पे उसे रिजॉल्व करेंगे. सो नीचे mg लग रहा है, ऊपर n लग रहा है, ऊपर ही f का एक कॉम्पोनेंट भी आ रहा है f cos थीटा, हॉरिजॉन्टल डायरेक्शन में f sin थीटा एंड लेफ्ट डायरेक्शन में f max इन ऑर्डर टू पुल, राइट. सो y एक्सिस से n मिलेगा तुम्हें. हाउ मच इज दिस n? mg माइनस f cos थीटा, और क्योंकि f भी mg दे रखा है So you can take common. So 1 minus cos theta. This is your n. Come on x-axis. To move, f sin theta must be greater than equals to f max. f max जो होता है वो म्यू n होता है और n यहाँ से रख दोगे. f के जगह के पे कैपिटल mg इंटू साइन थीटा ग्रेटर देन इक्वल्स टू कैपिटल mg 1 माइनस म्यू इंटू mg 1 माइनस cos theta. mg cancelled. Sin theta greater than equals to mu 1 minus cos theta. So mu should be less than equals to 1 minus cos theta. You know that sin theta को हम, क्योंकि ऑप्शन में केवल थीटा से आंसर नहीं मिल रहा है, we need to further simplify this equation and we are also observing theta by 2, so we should go for the half angle formula. So sin theta can be written as half 2 sin theta by 2 and cos theta by 2, 1 minus 1 sin square theta by 2 for 1 minus cos theta. एक sin theta कैंसिल आउट हो रहा है और 2 कैंसिल हो रहा है, so we are getting cot theta. So mu should be less than equals to cot theta by 2. D is the answer.